Hey guys, we are finishing our 0.2 notes talking about real numbers. So yesterday we went through the real number system and how to classify the numbers. We went through if you're given numbers, how do you classify them, starting with rational numbers and then working your way in, and then estimating and graphing them on a number line so that we can order them from smallest to largest. And then we finished up with having rational numbers that were repeated decimals. How do we go ahead and write that as a fraction? Today's notes are much shorter. We're getting into square roots and perfect squares and what that means for our classifications of rational and irrational numbers. So to start, it says knowing the perfect squares helps to simplify and classify square roots. So perfect squares include the numbers where if you take the square root of it, you get a whole number. So what that means, 1 times 1 gives me 1. I'm going to make my pen a little bit bigger here. 1 times 1 gives me 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And then 25, 36, 49. All the numbers you get from squaring your list of whole numbers. 49, we're at 7, so 8 times 8 is 64. 9 times 9 is 81. And then 10 times 10 is 100. So that's your list of perfect squares. Again, perfect squares means if I take the square root of it, square root is whenever you figure out what number times itself gets you something else. So perfect squares means if I take the square root, I get whole numbers. So square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and so on and so forth. So if you see the square root of a perfect square, that's always going to be a rational number because it's one of our whole numbers. We get into irrational numbers whenever you're taking square roots of something that are not perfect squares. So for example, if you're taking the square root of 7, 7 does not fall on this list. 7's not a perfect square. If you try to do that in your calculator, here's my calculator. So to take your square root of 7, you can see, sorry, I'm getting adjusted my camera. You can see that you don't get a nice, neat whole number. We're getting this decimal that doesn't terminate or doesn't end. And the other day we talked about how that meant it was an irrational number. There's no pattern here and it's not ending. So anytime you take the square root of something that's not one of our perfect squares, it's not something that falls on this list, it's irrational. It's important to note here that the list doesn't stop at 100. That's just where I ended it. You would just go on as much as you can. You're just squaring every number. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. Your list of perfect squares doesn't end. Okay. Whenever we're talking about perfect squares, we want to specify that every number has 2 square roots. Okay. So what that means, if, for example, I take the number 49, so I want to know what the square root of 49 is. So that's just asking me what times what gives me 49. Well, we already know that that is going to be 7 times 7 equals 49. So your first square root is always going to be your positive number. But if you remember about anything about negative numbers, 2 negatives always make a positive. So not only does 7 times 7 give you 49, negative 7 times negative 7 also gives you positive 49. So when we're talking about square roots, every single number has a positive and a negative square root. 7 times 7 is 49, negative 7 times negative 7 is 49. 6 times 6 is 36, negative 6 times negative 6 is also 36. What's important to also note is, maybe I'll write this in white so it's a little bit easier to see. You can never take the square root of a negative number. So keep in mind, that's not what I'm saying here. I'm saying my square root as the answer can be negative. What this is saying is that I can't figure out what is the square root of negative 49? Because if you remember about your negatives, you can never multiply two positives and get a negative or two negatives and get a negative. So we're going to talk a little bit more about your negative rules next week. I'm not sure how much you remember from last year because I believe that might have been right around where we were all sent home. So we are going to talk more about this next week, but just keep in mind that every number has a positive and negative square root. However, you cannot take the square root of a negative number. Okay, so moving on. Example 4 talks about simplifying square roots. Whenever we're simplifying square roots, we always want to keep in mind our list of perfect squares. So it might always be a good idea to kind of jot them down so we can go back to them for reference. And again, if you don't memorize them, you can just get them from doing the math in your head. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6, 7, and you keep going up. Again, I'll even write a little bit more on this page because we have a little bit more room. So that's 11 times 11, 12 times 12, 13 times 13, 14 times 14 is 196. If you do want to memorize these, it's easy to remember them up to 100. Some of you might even know up to 12. And then if you can add in remembering that 13 times 13 is 169, 14 times 14 I remember because look, my 9 and my 6 are just swapped. So I have 169 to 196. And then I normally go up to 15. So 15 times 15 is 225. So we want to simplify these expressions. So for question A, I have a negative sign on the outside. So I have the negative square root of 81 over 27. What might be easier to start is to reduce our fraction first. So I have 81 over 27. So if we're reducing fractions, think in our heads, what can I divide 81 and 27 by? I can divide them both by 9. So that's going to give me negative square root of 9 over 3. And then from here, if I'm taking the square root, well, what is 9 divided by 3? Remember, if I see fractions, I can always go ahead and just divide it. So maybe I didn't know what 81 divided by 27 is, but after I reduce it, I can see, well, I just have 9 divided by 3. 9 divided by 3 is 3. And notice in my work, I'm not getting rid of anything that I haven't used yet. I haven't used the negative sign, and I haven't used the square root. Okay, so now we're talking about estimating. So 3 does not fall on my list, right? I have my list down here. 3 is not one of my perfect squares. So this is going to be an irrational number. Square roots of these are always rational because it's a whole number. This is going to be irrational. So now I just have to figure out where in this list does 3 fall. So 3 comes in between 1 and 4. So maybe not only am I going to write my perfect squares here, maybe above them I'm going to write what their square roots are. So the square root of 1 is 1. Square root of 4 is 2. 9 is 3. 4. So I can see all of my square roots. 10, 11, 12, 13, and 14. Okay, so again, 3 does not fall on my list of perfect squares. I don't off the top of my head know what the square root of 3 is, but I know, again, we're specifying that these are all square roots. Just writing this out so you can kind of visualize what I'm going to say in a second. So 3 is not on my list, but 3 falls right in between 1 and 4. So if my square root of 3 is going to come right in between 1 and 4, then that means the answer is going to come in between 1 and 2, right? Because the square root of 1 is 1, the square root of 4 is 2. So the square root of 3, if that comes right in between my square root of 1 and 4, then the answer has to come in between 1 and 2. Since 3 is a little bit closer to 4, that means my answer is going to be a little bit closer to 2. So if I'm estimating what is the square root of negative 3, or I'm sorry, the square root of 3, we're going to keep that negative sign because we're really not doing much with it. It's going to be some number close to 2, so I'm going to estimate it. Maybe I'm going to estimate it to be about 1.8. Okay? And if we want to go ahead and check, in my calculator, I'm going to type in the square root of 3. And look, I was pretty close in my estimation. My calculator telling me that it's 1.73205 all the way down. So I can see this is my accurate answer here. It's my irrational number, not a pattern. I did my estimation here. I was a little bit off, but it's close enough. Okay. So my actual answer, if we want to go ahead and write it, I have 1.73205, and then it keeps going on. Okay. So if you're estimating square roots, you're just figuring out where do they fall and using your knowledge of perfect squares to get you where you need to be. Question B looks a lot easier because I notice that I have a 25 and I notice I have a 144, which they both fall inside my list of perfect squares. So for A, first thing I did was reduce my fraction because it made it a little bit easier. I don't know what 25 over 144 is going to reduce by, but I automatically notice that my fraction has two perfect squares in it. So I can take their square roots separately. So I'm going to keep my negative sign on the outside. My square root of 25 is 5. My square root of 144 is 12. So there's my answer. Negative 5 over 12. It's a rational number because it's written as a fraction. This one, not a rational number because it's that decimal that never ends or never repeats. Number 34. Part C says the square root of 34. Again, I'm looking at my list. I don't see 34 on my list of perfect squares, so I'm going to estimate about what it is. So my square root of 34 is going to come right in between 25 and 36, so my answer is going to be between 5 and 6. 34 is a lot closer to 36 than 25, so my answer is going to be a little bit closer to 6. So I'm going to estimate this to be about 5 point, I'm going to stick to my 8s. I'm just going to estimate it to be about 5.8. So let's go in and check. In my calculator, I'm going to type the square root of 34. Look, I was almost right on the dot there. So my actual answer is 5.830. And you can see that irrational number again. No pattern, no end. So if I write the accurate answer, we end up getting 5.8309. And then it keeps going on. Part D, also not a perfect square. 90 doesn't fall on my list, but 90 is right in between my square root of 81 and my square root of 100. So that means my answer is going to be in between 9 and 10. 90 is almost smack dab in the middle of 81 and 100. So that means my answer might be smack dab in the middle of 9 and 10. So I'm going to estimate this to be about 9.5. So square root of 90, let's check my answers. Look, I get 9.48. So let's write that actual answer, 9.486, so forth. And then my final part E, I notice I have nice neat numbers. 64 is on my list of perfect squares. 16 is on my list of perfect squares. So there's two things we can do here, right? I notice my perfect squares. I know what those are. I'm going to reduce this. Square root of 64 is 8. Square root of 16 is 4. So now I have 8 over 4. Well, in my head, I just know that that's going to be 2. Or you can reduce your fraction first. So I'm going to do my second method in a different color. So if I know what 64 divided by 16 is, 64 divided by 16 is 4. I didn't use my square root yet, so I'm going to keep that down in my work. 64 divided by 16 is 4, so the square root of 4 is also 2. So notice you get the same answers. Okay. So now if we go through, let's circle the ones that are rational numbers. So my rational numbers, this, I got funky decimal, doesn't work. Make sure that you're not looking at your estimated version because that's my terminating decimal. That was just my estimate. My actual answer is irrational. Here's a fraction. So this is something that's a rational number. Again, funky decimal, not rational. Funky decimal, not rational. Here I got the nice neat number 2. So B and E are both rational numbers. And then finally, moving on to example 5. This is pretty much what we did yesterday, but now we are throwing in the square roots. So we're going to do the same thing. We want to make sure that whenever we're looking at this list of numbers that they're all written in different forms, we want to translate them so they are all written in the same form before I can compare them. So starting here, well, I know that the square root of 25, that just falls on my list of perfect squares. The square root of 25 is 5. 4.6 repeating. I like the form that that's in. I'm not going to go ahead and change it. I have the square root of 15. If I go back up to my list, 15 is not on my list, but 15 is between 9 and 16. So my answer is going to be between 3 and 4. 15 is really close to 16, so I'm going to estimate my answer to be about 3.9. Again, let's check it. Square root of 15, 3.87. So pretty close. And now I have 4 3/8. So if you remember how to go from a mixed number to an improper, 8 times 4 is 32 plus 3 gives me 35/8. If I want to write that as a decimal, 35 divided by 8 gives me 4.375. So now I'm going to go ahead and make my number line. My smallest number is going to be this 3.9. My largest number is 4.6. So let's go 3. I don't need any negative numbers, so I'm just going to start here. Let's say 3, 3.5, 4, 4.5, 5, 5.5, and keep counting it. When you're making your scale, you can make it whatever you want. Look at your numbers, think about what might work the best. So now I have 5. Just going to go ahead and plot my numbers just like we did yesterday. I got 4.6 repeating, 3.9, then 4.375. So now ordering them from left to right, my smallest number here was the square root of 15. Remember, you always want to keep it in the same form. And then I have 4.375, so that was my 4 3/8. And then I have 4.6 repeating, and then finally I have the square root of 25. There's my list. So we're going to go ahead and do the same thing for part B. Let's change our impropers. So I have negative 9/4. So if you want to think about this in your head, 9, if I take 1 away from that, I get 8. So 8 divided by 4 is 2. So I'm going to get negative 2. And then I took 1 away, so that was 1/4 left over. So 1/4 is 2.25. So if you want to check it, 9 divided by 4, 2.25. Negative 2 7/10. Well, I know my tenths are just 0.7, so I'm going to say negative 2.7. And then I have negative 2.1, which is in a good form, but now I have this square root of 8. So if I go up to my list to try and estimate it, 8's not on my list. It's between 4 and 9. My answer is going to be between 2 and 3. 8 is pretty close to 9, so I'm going to estimate it to be about 2.9. So I'm going to say about negative 2.9. 1 is on my list, so square root of 1 is 1. Since I had this negative sign out front, I'm going to carry that down, and my answer is going to be negative 1. So now let's think about what our scale is going to be. My smallest number is negative 2.9, and my biggest number is negative 1. So how many lines do I have here? Perfect. So I'm going to say, I'm going to make this negative 3. That's not going to fit. Okay, let's go 0, negative 0.5, negative 1, negative 1.5, negative 2, negative 2.5, all the way down. So I'm going to plot negative 2 1/4, which will be here, negative 2.7, negative 2.9, and then negative 1. So going in order, negative 2.9, that was my negative square root of 8 as my smallest number. And then I had negative 2 7/10. And then I had negative 9/4. And then finally, my biggest number is the square root of 1. So there you have it. That's your discussion of square roots, what makes them rational, what makes them irrational. Anytime you have something like this where it's not on your list and you can't think about what it is in your head as a perfect number, that's irrational. Anytime I do have the square root of something and it's my whole number, meaning it falls on this list of perfect squares, that is rational. Okay? See you later, guys.